Now for the next session, as session chair is Dr. Sunil Kumar Khatri and chair Dr. Tamura. I request Professor Sunil Kumar Khatri and Dr. Tamura on the dais. Professor Dr. Sunil Kumar Khatri is working as Director for Amity Institute of Information Technology and Additional Director for Amity Directorate of Engineering and Technology for Amity University, UP, Noida. He is Fellow of IETE Senior Life Member of CSI, IEEE, IA, SC, SIT, and member of International Associations of Engineers, Hong Kong. He is Secretary in Society for Reliability Engineering Quality and Operations Management, Convener, MDC, and member, IEEE UP Section India Executive Council, immediate past Vice Chairman of CSI Noida Chapter, and Honorary Member in Governing Council of Delhi Chapter 3E Innovative Foundation. He has been conferred IT Innovation and Excellence Award for contribution in the field of IT and Computer Science Education by KRDWG at IIT Delhi in 2012. He has also been conferred with the Award for Exceptional Leadership and Dedication in Research during the 4th International Conference on Quality, Reliability, and Infocom Technology in the year 2009. He has the recognition of being listed in Marcus Who is Who continuously for the last 5 years. He is conferred with Honorary Visiting Professorship by Data Analytic Institute, University of Technology, Sydney, Australia in October 2015. He has edited 7 books, 7 special issues of International Journal, written 6 chapters, and published and presented more than 100 papers in international and national journals and proceedings. Dr. Sunil Kumar Khatri is editor of International Journal of Systems Assurance Engineering and Management, Springer. He is in editorial board of several journals from Singapore, Hong Kong, USA, and India. He is honorary associate member of 3 Insight, International Journal of Innovative Technology. His areas of research are software reliability and testing, data analytics, and pattern recognition. Now, I would like to invite Professor Dr. Sunil Kumar Khatri to introduce Professor Tamura.
It's my privilege to introduce to the House our speaker for this invited talk, Dr. Yoshinobu Tamura. Professor Yoshinobu Tamura had received the BSc, MS, and PhD degrees from Tottori University in 1998, 2000, and 2003 respectively. From 2003 to 2006, he was a research assistant at Tottori University of Environmental Studies. From 2006 to 2009, he was a lecturer and associate professor at Faculty of Applied Information Science of Hiroshima Institute of Technology, Hiroshima, Japan. From 2009 to 2017, he was an associate professor at the Graduate School of Sciences and Technology for Innovation, Yamaguchi University, Ube, Japan. Since 2017, he has been working as a professor at the Department of Industrial and Management Systems Engineering, Faculty of Knowledge Engineering, Tokyo City University, Tokyo, Japan. His research interests include reliability assessment for open source software. He is a regular member of the Institute of Electronics, Information and Communication Engineers of Japan, the Information Processing Society of Japan, the Operation Research Society of Japan, and the Society of Project Management of Japan, and IEEE. Now I request Professor Tamura to give his talk on reliability and maintainability analysis and its tool based on deep learning for fault big data.
Professor Khatri, thank you. My name is Yoshinobu Tamura from Tokyo City University in Japan. My presentation title is Reliability and Maintainability Analysis and its tool based on deep learning for fault big data. Okay, this slide represents outline of our presentation. First, we would like to introduce the open source software and the development paradigm of open source software. Next, we discuss the methods of reliability and maintainability assessment based on the deep learning for fault big data. Next, we develop the reliability and maintainability analysis tool based on deep learning for fault big data by using the latest programming technology. Also, numerical examples by using actual fault data will be also presented. Finally, I'll summarize our presentation. Many open source software have been developed under the many open source projects. For example, OpenStack open source software, cloud software developed under the OpenStack projects. Mozilla Foundation developed several open source software. For example, Firefox web browser, and Thunderbird, Mailer, and so on. Apache HTTP server, Hadoop database software, Flex SDK, Cat, and so on are developed under the Apache Foundation of open source projects. On the other hand, moreover, Android, Chromium are developed under the Google projects. This slide represents the developmental cycle of open source software. First, a developer develops the open source software, and the developer uploads the open source software to the website of open source projects. User downloads the open source software, and if user has a problem with open source software, user is bug contents upload to the bug tracking systems. Developer confirms the fault contents of bug tracking system. Developer modifies the open source software. Developer uploads the bug fix version and minor version, major version, and so on. Developer uploads the open source software to the website of open source projects. The development cycle of open source software is a simple structure. On the other hand, the waterfall software development style, it has a testing phase. On the other hand, the development cycle of open source software has no specific testing phase. Next, this slide represents a structure of deep learning. We focus on the deep learning. In this figure, LZ, ZL and ZM means pre-training units. Also, ON is the amount of compressed characteristics. Several algorithms in terms of deep learning have been proposed by several researchers. In this research, we apply the deep neural network to learn the fault data on bug tracking systems of open source projects. We apply the following amount of information to the parameters of pre-training units. The objective variable is given as levels of software reliability trends as shown in table 1. Reliability trends in case of positive. In this case, the coefficient value is 1. On the other hand, the reliability trends of negative. In this case, the coefficient value is -1. The structure, we apply two kinds of reliability trend level as a coefficient value to the amount of compressed characteristics, positive and negative, 1 or -1, respectively. The following 9 kinds of explanatory variables are set to the amount of pre-training units. For example, date recorded on bug tracking system, a name of a software product, a software component, a name of software version, a nickname of fault reporter assignee, the status of software fault, fault severity levels, major level, minor level, trivial level, and so on. Then the data of each explanatory variable are converted from the character data to the numerical values such as the rate of occurrences. Reliability assessment measure, the mean time between software failures, MTBF, is useful to measure the property of the frequency of software failure occurrence. We define the measure of MTBF, this equation 1. Where TK is case MTBF. DLK means estimated case index number as a coefficient value based on deep learning, 1 or -1. The index number 1 means reliability growth trend. On the other hand, the index number -1 means reliability regression trend. Also, SDK means case standard deviation. as given by the following equation 2. Similarly, the correction time between software failures, CTBF, is useful to measure the property of the frequency of software maintenance. We define the correction time between software failures as follows, this equation 3. Similarly, SDK means case standard deviation as given by the following equation 4. We develop the application software based on the proposed method. In particular, the developed software application is implemented by using structure as shown above in this figure. This figure shows the framework of our tool in this research. This tool is used the HTML file and ggplot2 stochastic programming statistical computing R, the library ggplot2 and ggplotly libraries. The specification requirement of the reliability and maintainability analysis tool based on deep learning for fault big data are shown as follows. First, this tool should be operated by clicking the mouse button and typing on the keyboard to input the data through a GUI system. In particular, the user experience design is adapted as an important element of our tool. The developed application software should be implemented by NWJS, statistical computing R, and HTML, JavaScript, CSS3, ggplotly as the latest technologies. This tool is developed as a native application on Windows, Linux, and Mac OS operating system. Also, this tool operates as a web application. The method of deep learning discussed in this research is used as a quotient value in the proposed method. Numerical examples. We focus on the Apache HTTP server in order to evaluate the performance of our methods and tool. In this research, we show numerical examples by using the datasets for Apache HTTP server as open source software. The data in this research are collected in the bug tracking system on the website of Apache HTTP server on open source projects. Next, this figure shows the main screen of our software application. We obtain 10,004 datasets from the data recorded on bug tracking system of Apache HTTP server. And then 90% of the recorded data is used as a learning data. Right side is a menu button of our tool. This slide represents the estimated 10-fold moving average correction time between failures based on deep learning. Red line shows the actual data sets, and the blue line shows the estimate by deep learning. MTBF and CTBF are useful for the software managers to understand the open source software reliability and maintainability by using our tool. X-axis shows the number of faults, and Y-axis shows the CTBF. The unit is the days. This figure shows the estimated 10-fold moving average MTBF based on deep learning. Similarly, the X-axis shows the fault number. Y-axis shows the MTBF, mean time between software failures. The unit is days. Red line shows the actual data sets, and the blue line shows the estimates by deep learning. This figure shows the estimated 50-fold moving average MTBF based on deep learning. Red line shows the actual data sets, and the blue line shows the estimates by deep learning. Okay. Similarly, this figure shows the estimated 50-fold moving average CTBF based on deep learning. Y-axis shows correction time between failures. The time unit is days. X-axis shows number of faults. Our tool will be helpful for the open source software managers to confirm the trend of reliability and maintainability in terms of the long-term prediction from 50-fold moving average. Sorry. Okay. Conclusion. First, at present, many open source software developed under several open source software projects. It will be useful for the software managers to understand the open source software reliability and maintainability. If many datasets recorded on the bug tracking systems are used for open source software project management, this research has focused on the method of open source software reliability and maintainability assessment based on the deep learning by using fault big data on bug tracking system. Moreover, we have developed the method of reliability and maintainability assessment based on deep learning. In particular, the developed application software based on deep learning is used to the latest technologies. For example, NWJS, statistical computing R, HTML, JavaScript, CSS3, ggplot2 library, and Plotly statistical R library. Then we can easily implement the application software by using NWJS technology and Plotly library of R. Also, several numerical illustrations of open source software reliability and maintainability assessment by using the fault data. Finally, we have shown the performance illustrations of our application software. Thereby, we have found that our tool can assist open source software reliability and maintainability based on the data on bug tracking systems. Finally, the developed application software is available from this URL. This URL is my laboratory website. Please visit this URL. Thank you very much for your kind attention.
Thank you very much. I request Khatri sir to conclude the session.
Any queries? I have a couple of queries. I'm waiting if anyone has, otherwise. Two queries to you, Professor Tamura. One is you had talked about CTBF, that's correction time between failures, and the equation you had given is CK is equal to CK minus 1 plus something. So that means you want to say that at any point of time K or the Kth failure, it's related to the last one. But technically, if we see, that can only be possible if the faults are ordered in terms of their complexity. Is it so? Had you taken that assumption in mind?
Yes, K is not a time.
Okay.
Yes, K is a fault number.
Mm-hmm.
Therefore,
previous one, that's CK minus 1.
Yes. Next.
So there is a relation between the next and the previous one. Okay. My next query, last one, you had talked about the fault big data. When you talk about big data, it has to be big data. What was the size of sample you had taken for this fault failures? What's the size of your big data?
Size of the
big data in your problem?
Big data. This data is 10,000 fault data. 10,000 fault data includes fault levels and
it is on open sources.
These data included this data, included fault big data.
And we will take this query after the this session also, and we will discuss further.
100,000.
Oh, okay, okay. Any queries you have?
A strong supposition here is respect to the data origin. So the data origin is okay, it's good.
Fine.
So what is your strategy for avoiding the effect of the outlier when you computing the mean, for example? What is your strategy for avoiding the effect of the outliers in the computing of the mean? Do you use, for example, mean and trim mean? What is your strategy? The mean mean time between failures. Okay. We see a figure with the mean time failures and the frequency. Yeah.
This figure?
Yeah.
Okay.
Number. How avoid the effect of the outlier here when you use the deep learning algorithm for approximate this function?
Function?
Yeah.
This function, blue line is based on this equation 1. By using equation 1, the estimated tenfold moving average MTBF is illustrated. Okay.
Thank you, sir. I request Khatri sir to present a memento to Professor Tamura. Thank you, sir. I request Mr. S.K. Jha to present certificate to Khatri sir.